Dr. Nimi Singh. Today I bring you the next learning episode in BSc Forensic Science on a very important unit of paper Digital Forensics, that is the fundamentals and the concepts, and part 2 for it. In this lecture, we will be studying about encoding methods and different formats along with the understanding of what is called memory and processor. We will also acquaint ourselves with the different methods of storing data. Finally, we will wind up this module by the conclusion of this learning episode. So, dear students, let us have a look at what we are going to learn today. The first thing that we will learn is encoding methods and formats, then memory and processor, then methods of storing data, and in the last, we will just conclude the session. Let us now come to the encoding methods and the formats, which is the first module. Now, in the computer system, as we know, data is internally presented as octets. An octet is a little unit of data that includes characters and numbers in binary form. Numbers may be represented in the binary, that is base 2, decimal, which is the base 10, octal, which is base 8, and hexadecimal, which is base 16. A computer system uses the binary pattern to represent characters and numbers. Often, an octet comprises of 8-bit, or it is also referred as byte. In other words, an octet refers to a symbol set which may represent alphabets, numeric and other symbols. Basically, there are 5 classes of characters which are given below. The first one is the alphabetic characters, that is the upper and lower case, then decimal digits, then punctuation, and then the control characters which are not usually printed, and any other, that is all other characters. In modern computer system, to represent character set, the following standard techniques are used. Each technique encodes a single character into an 8-bit octet, that is EBCDIC, that is extended binary coded decimal interchange code. Then you have ASCII code, that is the American Standard Code for Information Interchange. Then you have Unicode, a modem extension of ASCII. Then extended binary coded decimal interchange code. Let us study this first. Now, IBM developed extended version of binary coded decimal representation method, that is referred to as EBCDIC. To encode every character, this method use 8 bits. Inversely, BCD method used only 6 bits for encoding characters in 64 distinct characters. Some of the characters represented in BCD were the 26 uppercase alphabetic characters, that is A to Z, the 10 digits 0 to 9, the space character, then the symbols used in arithmetic, that is plus, minus, multiplication, division, equal to, and AND. Then we have punctuation marks. Now, the following figure shows the character representations in EBCDIC code. The International Business Machine Corporation, called IBM, by everybody, developed the EBCDIC standard on the same occasion that the ASCII standard were being developed. The EBCDIC standard was developed for use in the IBM system /360, a revolutionary computing system which was introduced way back in 1964. IBM supported the ASCII standard strongly. This leads to a simple question: why did IBM not use ASCII? Here is a little known fact. While the computers in the IBM system 360 line were designed to use the EBCDIC standard, each had an ASCII switch that would cause it to use ASCII. Few system administrators knew of this ASCII switch and fewer still used it. When the system /360 evolved to the system /370, the switch was then dropped. IBM used EBCDIC because it was compatible with the existing card codes, American Standard Code for Information Interchange. Let us study this now. ASCII has its own set of control characters with meanings which are similar to those used in EBCDIC. Here are the ASCII codes for printable characters. There are 128 code values in ASCII ranging from 0 by 00 to 0 by 7F. The value 0 by 20 is the ASCII code for the space character. Now, the value 0 by 7F is the ASCII code for the delete character called del. ASCII has a number of interesting features that make it appealing to a programmer. Suppose we are examining a value which is stored in a variable. If the value falls in the range 0 by 41 to 0 by 5a, that means the value represents an uppercase character. But if the value falls in the range 0 by 71 to 0 by 7a, the value represents a lowercase character. For each alphabetic character, the code for the uppercase and the code for the lowercase are strongly related. Only one bit is reset. Look at the codes for the letter A. We give these in binary as capital A, that is the uppercase A, represents 01, 000001, while the lowercase 011, 00001. Now, the figure represents the character representations in ASCII code. Now, let us study about the Unicode as an extension of ASCII. The ASCII code set and the EBCDIC code set are each sufficient for expressing any idea as long as it can be expressed in standard Latin characters, that is the character set used to write in English. This is not an issue when writing programs, as all programming languages can be expressed in something that looks like English. But suppose your company wants to market an application in a country such as Korea, Japan, China, Egypt or Saudi Arabia, in which English is not the main language. How do you design your GUI, that is the graphical user interface, for the screen displays? So, one option is to require that everybody learn English, which is almost a de facto requirement anyway. Suppose that you want to market an application to be used in a small shop such as a corner market or a cobbler shop. Should grandpa learn English? A better way is to develop a method to represent non-Latin characters. Let us now come to the second module, that is the memory and the processor. Memory, let us first discuss this. Now, computer consists of three major components: the input unit, the central processing unit and the output unit. Memory is one of the essential components of central processing unit. Memory stores smallest unit of data in volatile and non-volatile mode. Alternatively, memory is a set of circuits that store instructions persistently or non-persistently. It is vital processing element of the computer system. It has different types. Let us first discuss the main memory. Main memory is also known as the primary memory of the computer. It stores the instructions of process, unit of data and information. The nature of data is stored in this memory is volatile. That means the data is lost due to power failure. Volatile property of the memory leads to non-persistent storage of data. The main memory has the following types. The first one is the RAM, that is the random access memory. It refers to a temporary storage that stores data currently used by the processors. It keeps a record of the program and data recently used by the system. System performance depends on it. That means if more RAM has been allotted to the computer, that is, if the computer has more RAM, then it processes data or programs. Now, data or records contained in RAM are lost when computer is turned off. Then comes the ROM, that is a read-only memory. Now, read-only memory is non-volatile memory which keeps data in itself even when the computer is turned off. It stores instructions regarding the computer manufacturers. It also contains booting program of computer that is known as bootstrap loader. The function of this program is to initiate system software working when the computer is turned on. Now, ROM may be programmed by the user or the manufacturer. In ROM, user can keep only readable data instead of read or write access. Example of such type of ROM is PROM, in which the data stored once may not be modified. To extend this, and another form of ROM is known as erasable PROM, which enables user to remove data stored on it and then further store a new data. Now, other types of main memory are the CPU registers, the cache memory. Now, let us come to the secondary memory. Now, secondary memory also refers to as auxiliary or backup storage. It stores data permanently and enables the user to remove and change data easily. It is used to take backup of data persistently in computers. It is more economic to have a main memory and may contain a huge data. For example, hard disk, magnetic tapes, the floppy disk and flash drive all comes under this type of memory. Now, let us differentiate between storage versus memory. Let us now distinguish between a storage and a memory. Now, we will first discuss the different major points of distinguish between storage and memory. Now, storage is non-volatile in nature while the memory is volatile in nature. The storage can store large amount of data while the memory has a limited storage capability. It uses to take up the data, but the memory is used to just the processing of data. Now, storage refers to as auxiliary memory while the memory is nothing but the main memory of the system. Now, example of storage memory are floppy disk, hard disk, magnetic tapes, while the examples for the main memory are RAM and ROM. Let us now come to the processor. Like human brain, the processor is nothing but the brain of the computer system. It is also known as microprocessor or so-called central processing unit, that is a CPU. It accomplishes all types of operations and coordinates tasks which are performed by other system parts such as input-output devices, memory and disk storage. In general, it is an electronic circuit that resides on the motherboard of the computer system. Now, let us come to the processor design. A processor runs the programs that include different user applications and operating system itself. Programs are set of instructions that represent in machine language, which executes more or less in a sequential order. The efficiency of processors depends on its internal design, that is known as the architecture. Processor architecture is designed to focus speed for the execution of instructions. Apart from these, how processors communicates fast, the backup information back and forth with external cache and other system components specified by external design of it. Let us now discuss the processor components. Today, processor comprises of various internal elements which are defined below. The first one is the execution unit. This unit is the heart of processor that processes instructions of programs. Then is the branch predictor. This tries to predict where the program will actually switch further. It also allows to prefetch and decodes unit for retrieving instructions. Then is the floating point unit. It is the conceptual unit that optimized to accomplish real number calculations much faster than general purpose conceptual unit. Now then we have is the primary cache. It is little portion of the fast memory that enables a processor to fetch data quickly instead of slower memory. Then you have bus interfaces. It defines the path that connects the microprocessor to memory and other elements. Suppose modern processors connect to the chipset north bridge through a separated bus known as front side bus or host bus. Now, let us come to processor architecture. Now, clock cycles increase day by day, but rule of physics limit how fast the processors can run. If processors are designed to focus clock speeds for the better performance, then it results in enhanced processor performance. Wider data buses and registers. Specific to clock speed, amount of data processed in single operation leads to the amount of work done. Previous processors used to handle 4-bit or 8-bit data, whereas modern processor process 32 to 64-bit. Then we have is the FPUs. Now, to process floating point numbers, earlier processors required large number of operations. Inversely, it works well with integer numbers. Modern processors have a dedicated FPU that deals with the real numbers. Then we have is the pipelining. In previous processors, to execute an instruction, 5 ticks of clocks were taken. Each one loaded the instruction, decoded, fetched the data, processed the instruction and wrote the result. To enhance processor speeds, pipeline methods are used in modern processors that enables the process to execute one complete instruction per clock cycle. Then let us come to the superscalar architecture. Further, to extend more speed of the processor, many pipelines uses to enable multiple instructions in parallel way that refers to as superscalar architecture. This type of architecture of processor processes more than one instructions per clock cycle. Now then comes the Intel processors. Today computer systems use either Intel processors or Intel compatible AMD Athlon processors. Generally, computer systems that have Intel processor and Microsoft operating system. Though here the term Winter is used, which defines computer run Windows on Intel or compatible processor. As earlier processor naming convention, Intel processors known as 8086, 80186, 80286, etc. In general, Intel processors are known as x86. With time, Intel company provided 7 generations of processors to focus speed. Each of the generation of processor is defined here. The first generation. The first generation processors were using 16-bit for all kind of communication and processes. In this, 8086 was the first processor which was used after 1970s in mini computers like Display Winter and the system by 23 Data Master. It was dedicated to word processor also. Then comes the second generation. Now, second generation processors are 5 times efficient than an 8086 processor family on the similar clock speed. The 80286 processor based on the IAP X32 offered a quantum leap in its executing way. It was introduced in 1982 as follow-on of first generation processors. Now comes the third generation. The 80386 processor came as the third generation that shortly were named as 386. It was the first 32-bit processor that used 32-bit address bus for all kinds of communication. It was present in different versions such as 16, 20, 25 and 33 megahertz. Then comes the fourth generation. Next generation processor is 80486, that was shortly named as 486. It was produced in 1989, which advances in form of inbuilt floating processing unit with 8 KB of L1 cache as well as 32-bit address. It was provided a speed from 20 megahertz to 50 megahertz. It is also available in 486 DX, 486 XS versions. A 486 DX processor was without FPU and was referred to as 486S. To disable the 487SX installed 487SX in the coprocessor socket. It enhanced the form of the third generation. Now, let us come to the fifth generation. Processors of this generation are known as Intel Pentium. It offered high performance as compared to its earlier generation by incorporating various design improvements. It enhanced the speed by using a 64-bit address instead of 32-bit. It also increased the CPU memory bus speed from 33 megahertz to 60 and 66 megahertz. Now comes the sixth generation. Processors of sixth generation came in 1995, known as Pentium Pro. It also includes Pentium 2, Pentium 3 and Celeron processors. Later, this generation Intel desktop processor transferred in initial level system before 2002. At mid of 2002, it was discontinued as mainstream products. Then comes the seventh generation. Nowadays, seventh generation of processors are working in the computer system. It covers Intel flagship Pentium 4 with several Celeron processors depending on Pentium 4 design. It provides more speed as compared to the earlier processor. Now, let us come to the third module, that is the methods of storing data. Now, modern computer system deals with data which are available in different forms such as text, programs, images, audio and video. Here, the term multimedia is defined, which represents data as combination of text, image, audio and video like web pages, Google Maps, data, etc. When we use the computer and deals with all types of data, then one question arises in our mind: how the data is stored in hard disk. Now, to answer this question, all types of data are converted into uniform representation which is convenient to computer hardware. This representation is refers to as bit pattern. For example, to store integers data which are numbers like 230, 12, 212 and many more. To represent signed and unsigned integers, we have different ways. Now, unsigned integers are non-negative number that simply gets converted into binary form and represented in n memory address location. For example, we want to store number 7 in computer system with 8-bit memory location through unsigned representation. Though the number is converted into binary, that is 111 to the base 2. Afterwards, 5 zeros added prefix of 111 to make it an 8-bit representation, that is 000000111. In this example, generated number in binary is stored in memory location. Here, subscript 2 represents the number is in the binary representation, that is the base 2. Subscript is logical representation. It is not stored physical in memory. Further, sign and magnitude representation method came to represent positive and negative numbers. The present limit of unsigned integers, that is 0 to 2n minus 1, is split into two similar sublimits. Positive numbers are represented by first half and negative numbers are represented by the second half. Here, two different ways to represent 0 are given below. In this type of representation, if 0 is in the leftmost bit, then it is positive, otherwise the number is negative, that is shown above. Another of it, supposes we want to store a positive number, that is plus 28, through sign and magnitude representation in 8-bit memory location. Therefore, the number ID is then converted into 7-bit binary number, and 0 is to set at leftmost bit of resulted 7-bit number. Finally, the number is stored in 8-bit number. Inversely, to work with negative numbers, that is minus 28, means to store a negative number, then it is again converted into 7-bit binary number, but then 1 is set at leftmost bit of resulted binary number to make 8-bit number. Now, finally, the resulted 8-bit number is then stored. In other ways or reverse, suppose we want to display the integer which is stored as 01001101 via sign and magnitude representation. So, in this number, the leftmost bit is 0, that represents the positive number. Now, remaining bits 1001101 is converted into its decimal equivalent, which is 77. So, the final integer would be plus 77. Secondly, suppose we want to display the integer which is stored as 11001101 via sign and magnitude representation. And this number, the leftmost bit is 1, which represents that the number is negative, and the remaining bit is converted into decimal equivalent, which is 77. So, the final integer number would be minus 77. Additionally, a real number is a number with an integral part and a fractional part. For example, 23.7 is a real number. The integral part is 27 and the fractional part is 7/10. Although a fixed point representation can be used to represent a real number, the result may not be accurate or it may not have the required precision. The next two examples will explain why is this so. For example, in the decimal system, let us assume that we use a fixed point representation with 2 digits at the right of the decimal point and 14 digits to the left of the decimal points. That means a total of 16 digits. So, the precision of a real number in the system is lost if we try to represent a decimal number such as 1.00234. The system stores the number as 1.00. Apart from the number presentations, a section of text in any language is a sequence of symbols which are used to represent an idea in that language. For example, the English language uses 26 symbols A, B, C, etc. up to Z to represent uppercase letters and 26 signals to represent lowercase letters. 9 symbols, that is 0 to 9, to represent numeric characters, and then we also have symbols for punctuation marks. Other symbols such as blank, new line and tab are used for text alignment and readability. We can represent each symbol with a bit pattern. In other words, text such as cats, that is CATS, which is made up from 4 symbols, can be represented as 4 n-bit patterns, each pattern defining a single symbol. Now, audio is a representation of sound or music. Audio is not countable. It is an example of analog data. Even if we are able to measure all its values in a period of time, we cannot store these in the computer's memory, as we would need an infinite number of memory locations. Audio varies with time. Today, the dominant standard for storing audio is MP3, short for MPEG layer 3. This standard is a modification of MPEG, that is the Motion Picture Experts Group compression method used for video. Let us study this now. It uses 44100 samples per second and 16 bits per sample. The result is a signal with a bit rate of 705600 bits per second, which is compressed using a compression method that discards information that cannot be detected by the human ear. Images are stored in computers using two different techniques, the raster graphics and the vector graphics. Let us now conclude this module. Now, the data is represented in the various forms by user, but computer only presents in bit pattern. Here different format and encoding methods are discussed which are used for the computer system. Further, this chapter has introduced the concept of memory units and its categories as the main and the secondary memory and their characteristic features. It discusses the features of RAM, ROM, PROM and EPROM, auxiliary storage devices like magnetic tape, hard disk, floppy disk are also discussed. At last, processors, its components, its architecture and generations have also been discussed. Additionally, data storing methods also were covered at the last section of the chapter. With all this information, here we come to the end of today's lecture. Do keep in mind what we have discussed today. I will be back with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQs, quizzes, LORs, etc. Thank you for your time today. I will see you in the next lecture. Have a good day.